Hello everyone. Today we are going to start the topic trusses. Let's begin with the introduction to trusses. Truss is a structure composed of members which are fastened together in a way to resist change in shape. So what does this mean is that there are several members like this, 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 this and this. This is just an exemplary picture in which you can see that there are these five different members which are joined together so that when pressure is exerted, it does not leave its place. None of the members will leave their place upon exertion of force on this structure. So a truss is a structure comprising of one or more triangular units constructed with straight members whose ends are connected at joints referred to as nodes. So as per that definition, this is a node. All these where the connections are happening are nodes, and these are the members which are being joined. And all of them are creating triangular units. So this, as you can see, this is a triangle, so is this. So that is one thing which is going to be common in all the trusses. Now the purpose is to support a larger load or span a greater distance, to support a larger load or span a greater distance than any individual member from which the truss may be built. So if there is a area which needs to be covered or which needs to be connected, one point connected to the other like in a bridge, or a big space which needs to be covered, trusses are used because small members joined together are better in covering spaces than one single member, which will have less of the structural integrity as compared to when you are building up a truss out of these smaller members. अगर आप लोगों को ये बात समझ में नहीं आई तो मैं हिंदी में फिर समझाती हूँ कि पर्पस क्या है ट्रस बनाने का, कि इट इज टू सपोर्ट अ लार्जर लोड, कि कोई बहुत बड़ा लोड है जिसको अगर आपको सपोर्ट करना है तो इंस्टेड ऑफ एक मेंबर को यूज करने के बजाय कि आप बहुत बड़े स्पैन के अंदर सिर्फ एक मेंबर यूज करें, उसके बजाय आप ये करते हैं कि आप ट्रस बनाते हैं जो कि छोटे छोटे मेंबर्स का कॉम्बिनेशन है, जिससे आप एफिशिएंटली या तो एक बड़े स्पैन को कवर कर सकते हैं या एक बहुत बड़े लोड को सपोर्ट दे सकते हैं. So simply put, a roof truss is a framework of triangles designed to support the roof covering or ceiling over rooms. Now, why are we talking about only roof covering and ceiling over rooms? Because that is what you have to study in this semester. Short span structures up to 6 meters only. Now, how do trusses work? Trusses कैसे वर्क करती हैं वो अब हम समझते हैं. External forces and reaction to those forces are considered to act at only nodes. So external force क्या होगा? Atmospheric pressure, or if it is a roof, people walking over it. Although truss के अंदर, if it's a flat roof, people may walk over it, but trusses, the ones which you are going to study, are going to be triangular and sloping. So you can surely say that no one is going to walk over a sloping roof. So external forces and reactions to those forces are considered to act only at the nodes. So nodes are these. This is a node wherever the connection is happening in the truss. So all these nodes are the places where all the forces are acting. Now all the joints in a truss are treated as pin joint or hinge joint. So these are pin joints, and if you think about it, these two pin joints will act as a hinge for this member. So hinge and pin joints now result in forces in the members which are either tensile or compressive forces. So there are two kinds of forces which are acting in a truss, which is the first one is tensile and the second one is compressive. So as you can see, the members which are above, like this one and this one, these three are in compression, and the intermediate members are in tension. Okay, these are the basic things that you need to understand about how trusses work. Now there are two kinds of trusses, plain versus space trusses. The difference between the two is that plain trusses में सारे के सारे members apply the load in a same plane, and the truss is also a planar structure which is working in a single plane. So all members of the truss and applied load lie in the same plane. As you can see, this is the example of a planar truss. And this is an example of a space truss. If I can tell you how to understand this very simply, it will be by you understanding that a planar truss, you can measure it in two dimensions, x-axis and y-axis. And for a space truss, there will be three dimensions, x, y, and maybe z. So in a space truss, the members may be moving in the different three coordinates, x, y, and z, coordinates and planes, while in a planar truss they will only move either horizontally or vertically, but in a same plane. So an elementary space truss consists of six members connected at four joints, six members, four joints to form a tetrahedron. So this is the formula that is used for a space truss. M is the number of members. So the number of members equals 3 times number of joints minus 6. And in a plain truss, the M, which is number of members, equals 2 times number of joints minus 3. So you can see the difference, how this is actually creating a tetrahedron, which is a three-dimensional figure, and in this it is a two-dimensional figure made up of triangles. Now let us understand some roof truss terminologies. We'll start with the things which you almost already know. From this wall to this wall, the distance is called clear span, and from the center of where the load is the effective span. So if you want, you can write the definition as I'm saying it, that the clear span is the clear distance between two adjacent supports. These two supports are adjacent to one another, so that's why they are adjacent supports, and the distance from wall to wall face is the clear span, and the effective span is the center to center distance between any two adjacent supports. So these two are the supports. As you can see, there is a difference between just placing the truss on the wall and having a separate support system for the truss. So they are taking its center on both sides and then taking the distance between the two, and that is the effective span. Please don't forget this. Now the thing which you see here, is the cement block, which has been placed to provide a better support for the truss. So it's provided on both the sides, as the truss is resting on both the walls. Now over that is the base plate. This is the cement concrete block which we discussed before. Now comes the base plate. I'll highlight it. So base plate is the first thing which is put on the wall to support the truss. That creates a base, a metal base uh, for the truss to sit on. So here is the base plate. Over that is the cleat, which I'll highlight with another color. So here is the cleat, like this. I will explain it to you later. So a cleat is a supporting element used to support rafters and to prevent purlins from tilting, and it is also used to facilitate connections. So here the cleat is being used to facilitate connection only. Here the cleat is for connection, and here the cleat is for support. We will discuss this further. Now comes the gusset plate. So gusset plate is something that has been provided to connect the cleat, the base plate, the main tie beam and the rafter. We shall understand what all these things mean, but a gusset plate, if you want you can write, is used to connect beams and columns together and used to form connections by welding or bolting. So as you can see here that the gusset plate has these small circles. These are bolts which have been fixed into the gusset plate through all these different members. Now comes the pitch. Now here it's written that the pitch is 30 degrees, so that is what the angle is between the main tie beam and the principal rafter. So this angle is 30 degrees, and that is the pitch of the truss. Now the apex of the truss and this distance, this is the rise of the truss. Now what is node? You have heard this before when I was explaining the introduction to you. All the points where there are connections are nodes. Now we come down to struts. Struts are members on which compressive forces are acting. So these are struts where the compressive forces are acting. This is also a strut, this is also a strut, and this is also a strut. All the intermediate members are struts. Now we come down to the main tie. What is the main tie? The main tie is the member on which the tensile force is acting. So here is where the tensile force is acting. Here is where the compression is happening. So I'll write it down here. Compression. And this is tensile force. So here will be tension. Now the principal rafter, that is the thing which is here on top. So principal, it is the topmost angular member. It rests on the end of the main tie beam. So here you can see that the principal rafter is resting on the tie beam. Please don't see this as the thing which you have to understand. This is only for making you understand the terminology of roof trusses. This is not the kind of truss that you have to study. This is for a larger span. Okay. Now we come to purlin. What is a purlin? A purlin is a member which acts as a support for the roof. So, like I said before, here the cleat is supporting. So what is it supporting? It is supporting the purlin here. And what does the purlin do? This is the purlin. Purlin does what? It supports the roof or whatever covering structure that you are going to provide. So it creates a base for where the roofing structure is going to be attached. Now we come down to panel. Panel is the distance between two nodes or the length of one member wherever the node is also happening, wherever a connection is happening. So panel is the segment between two adjacent joints. Now we come up to the apex or the ridge. Now this is the apex point of the truss, and this is where the ridge is, this distance, and it is usually covered by a ridge capping which can be either in two parts, one put over the other to prevent water from seeping through, or a single member which covers the whole ridge area. There are a few other things also which we shall understand in the further slides. So let's go over the types of trusses that are built in steel. This is a very generic list as per the span which is being covered with the truss. So there's king post truss, which you studied before in the previous semesters, which is for a span of from 6 to 4 meters. And there's the raised cord truss, in which the cord is raised here. The main tie is in two parts, and it's at a certain angle. Then there's this scissor truss, which is also for from 4 to 6 meters of span. And then the king post truss. King post truss, which the difference between king post and king post truss is for 6 to 9 meters and 4 to 6 meters is that in 4 to 6 meters there's just one vertical component, and in span for up to from 6 to 9 meters there are intermediate members, the struts, since the length or the span is increasing. There is another type of a scissor truss, just like with the king post truss, for a bigger span like 6 to 9 meters there are intermediate members which are being provided. Then there is simple truss, in which all the intermediate members are at an angle and there's no vertical support. So since there is no vertical support, so these members are the ones who are bearing the load. And these are all four different members. This is different, this is different, this is different, and this is different. There is hoe truss, H-O-W-E, hoe. This type of a truss is usually built from 9 to for spans up to 12 meters. And there's span fink, compound fink, and another type of hoe truss. Now, in a hoe truss, you can see that there is this structure being maintained here, like this. And in this one, where the span goes from 12 to 15 meters, the distance between this distance which we read about, the distance between two joints is lessened and the number of members are increasing. And here this distance is more as compared to the hoe truss, which is being built for 12 to 15 meters of span. Now there's span fink truss, cambered fink or French truss, north light or sawtooth weaving shed truss, and modified north light truss. So usually north light trusses are built, as you can see by the name, that in the direction where the north light can enter inside. So this is usually for a higher height of roof, and usually in places where industrial buildings are there and factories and warehouses need this type of roofing. Now let's go over the details for trusses for short span, which is up to 6 meters. Now we'll begin with the thing which we started the terminology from. So here, this is the concrete block which we studied in the terminology also. So this concrete block is there, and since it creates a bedding for supporting the truss, it's also called a bed plate cement concrete block. Okay, now this is the ratio in which the cement, sand and aggregate are mixed for this bedding. So 1 part cement, 2 parts sand and 4 parts of aggregate. Okay. And the size which has been given here is 200 mm by 200 mm by 300 mm. Now as you can see that there is this wall which is of the size 300 mm and the bed plate is 200 mm by 200 mm. So this takes a substantial this is a very substantial size and takes up more than half of the wall itself. So you can understand that this is for support and it does that only. Then the second thing which we studied there was this is the bed plate, the one which I am coloring with green. So this bed plate is made with metal. This is not made out of wood or cement. This is a bed plate which is fixed inside the bed plate cement concrete block using bolts and screws. So this is a rag bolt. This is called a rag bolt, which is 150 mm long. So please note that down and make sure that when you sketch you remember that to fix the bed plate which has been colored with green to the bed concrete bed which has been highlighted with yellow, to fix these two together they use a rag bolt which is 150 mm long. So the size of the bed plate is 200 by 200 on this side, this face that you can see, and up to 150 mm the rag bolt is going inside. Then after the bed plate, to fix the bed plate and the gusset plate, they use cleat. We have seen that what cleats are required for. Now I'm going to highlight the cleat with the blue. This is the cleat which has been fixed to the bearing plate, the base plate, with bolts. So there are 3 bolts which have been fixed and the size of the angle or the cleat is 75 mm by 75 mm by 6 mm. So 75 by 75 is the size of the angles, the equal angles, and 6 mm is the thickness. So if I draw it, here I'll draw it. This is the angle, 6 mm is the thickness. This is the thickness and this is the angle. So this is 75 mm and this is 75 mm. Now let's go over the next element, which is the gusset plate. So the gusset plate is this whole member that I am highlighting right now. And it goes behind the blue part as well. I'm not coloring that part so that you don't get confused, but it goes behind the cleat and the cleats are on both the sides. Since the wall is 300 mm by 300 mm and this the bed plate is 200 mm by 200 mm by 300 mm, as you can see here, the bed plate has to cover the whole concrete block, and the cleat will be on both sides of the gusset plate, which I have just highlighted with this orange or deep yellow color. Then the gusset plate and the cleats hold the gusset plate in place, and then the main tie and the principal rafter are fixed onto it. So I am going to highlight the main tie with a dark green color. This is the main tie fixed to the gusset plate, and I'm going to use the purple color for the principal rafter. This is the principal rafter, which is also fixed to the gusset plate using bolts. So as you can see, this is here you can see some terminologies or words which say C is cover minimum 1.5 dia of rivet. P is for pitch of rivets. Pitch means the face that you see, and 12 mm is the dia of the rivet. So here you can see it's written C. So this is the cover distance. This is the pitch. Pitch is, I'm really sorry. Pitch is the distance between center to center distance between two consecutive rivets or bolts. So this is how they are fixed. That distance, the cover and the pitch is also determined before. Then now I hope you understand how all these things are fixed together. Now moving on, if there is a when the truss is being designed, the nodes, this part, the nodes are set that where the node is going to be, and it is also decided how many members are going to go through the nodes. So here for a short span truss, at 1/3 distance of the whole span. So distance 1/3 distance from support till the 1/3 length of the span. Here the first node is provided where they place a gusset plate with which they fix struts. The struts which are the intermediate members which are in under force. So I've colored them with red. And as you can see, the principal rafter is going all the way up to the top at an angle, the angle which is called pitch. And the intermediate members are perpendicular to the principal rafter. So if this was at 30 degrees, you can guess what this angle is going to be if it is perpendicular there, and same for this angle. Now at the apex point, there is another gusset plate which has been fixed, and the gusset plate again is used to connect all the members that are there in the truss. So these intermediate members, which means this one, this member, the two principal rafters, are all connected with the gusset plate, which is given here, and all the gusset plates are 6 mm thick, and there is a distance of 200 mm which has to be developed. So we shall talk about that more. Now as you can see, now moving on to the next thing which we have to discuss, which is the apex. So this is the apex point where both the principal rafters are just meeting, but they are being connected using the gusset plate like we have discussed. And over these principal rafters, here you can see these things which I am circling. So what are these? We shall discuss this in detail now. So this is the principal rafter, which I am going to highlight with the color yellow. This is the principal rafter, okay? And the principal rafter is also an angle. We will see three-dimensional pictures of them in the video to come. So don't worry about it. You'll be able to understand it then. Here also you can see the things which we discussed in the previous slide. CPPC. So this is the cover. This is the pitch again, and the cover. So this is the principal rafter. Now this is a J bolt, the one which I am highlighting with red. So as the name suggests, it is in J shape. That's why it's called a J bolt. But it is provided so that due to winds or due to other forces, the covering over the truss does not come off. So it has a stronger uh, hold on the covering, and it makes a stronger connection, you can say. Now, the one thing which you see in black, which has been highlighted with black already in the drawing, which I am pointing out with the green colored arrow, this is the cleat. So cleat here is for supporting the purlin. Purlin, we saw what a purlin is. I'm going to highlight this with blue color. So what was a purlin? Purlin was a support which was there to hold the covering over the truss. So you might feel, why do we need a purlin, such a small member, to support the covering over the truss? But purlin, here you can see it in a section, but a purlin moves from the starting of the truss, matlab one end of the truss, till the end of the truss. Uh, it is not a small member, it runs through and through the length of the truss. So this is a through and through member. So a purlin moves through and through, and a cleat is only where the support is needed. So this there are two sets of bolts. One is the J bolt, which is fixing the fixing the covering. This is the covering member with the principal rafter, the cleat and the purlin. And there is a screw here. As you can see, I am pointing this out in red again. This is the member which is holding the cleat, the purlin and the J bolt together. Okay, so the smaller one is the one which you see which is going horizontally like this. This bolt is 12 mm bolt and nut, and the J bolt is a 8 mm dia J bolt. And there is also a washer that has been provided there. We shall see three-dimensional images of this mechanism. So please don't worry. Try to understand it right now. If not, I will explain it to you in a better way. So the green colored member is the covering over the whole truss, the whole structure, which is essentially the roofing. This is the mechanism, this whole thing is the mechanism which is holding it all together. And the one in yellow, the member in yellow, is the principal rafter. Now, you have to understand that since the truss is being placed from at certain distances to make a covering, and over that the roof structure, the covering is being provided, which is being held on by the purlins. So this whole area which I circled right now, this is prone to let water in when, if in case rains appear, water appears. So to cover this point, sorry, to cover this point which has been highlighted with the red, we provide a ridge covering. So as you can see that the ridge covering is going all the way from here like this, one part, and the second part is going over the first part and then like this, and it is being fixed with the J bolt along with the roof covering, the purlins, the cleats. So this is how they ensure that the ridge is covered with a ridge piece and that water is unable to come in. And also this overlapping is important so that it does not leave its place, and it maintains the structure which is being built, and it does not move around very much. And this also, like the purlins, goes through and through till the length of the roofing that has been provided. Now you can see that there is a plan here, a plan of the wall where the concrete block and the gusset plate and the base plate all were fixed with using cleats, so you can understand how the mechanism works even better here. So in this plan you can see there's a 400 wall. In the elevation it was written 300, so it depends on what kind of a structure you are building, the width of the wall. So here it is showing that there's a 400 wall and you can't see the concrete block underneath, and I'm going to use the same colors that I used in that section so you understand it a little better. So the part that I'm highlighting right now is the base plate, under which is the concrete block in which this has been fixed, and there's a slot hole for expansion. So when you fix the base plate to the concrete block, and since concrete and metal both are weathering materials, they do have an effect of the changing weather, so there's an expansion, the hole for expansion. So um, if the structure of the material changes, it does not affect the strength of the structure. Okay, then there is the cleat which was colored with blue in the previous slide, so I'm going to use the same color. This is the cleat. As you can see, it's an angle. So this is the where you can see three slots. This is the plan, one edge, and with dark blue I'm going to cover the this part. So this is what you were seeing in elevation there. So this is one cleat and this is the other cleat on both sides of the gusset plate. So these are the two cleats, and this, the black highlighted member, this is the gusset plate as it's shown here. It's marked here as well. This is the gusset plate which is holding everything together, in which all the bolts and screws are fixed. Now this you can see, the one which I have colored in dark green, highlighted in dark green. This is the main tie. These are also two angles which have been fixed on both sides of the gusset plate using these bolts. So the gusset plate is the thing which is holding all the members together, all the different members, and it is acting like a tie for all these. And this is the main tie to JLISA 6068 So this means, what has been written means that there are two angles which are of dimension 60 by 60 by 8 So if I try to sketch here, this is going to be one angle, as you can see, like this. It will be 60 by 60 by a certain thickness, as given here it is 8 This is the first member. Here is where the gusset plate is going to be. I'm just making a schematic diagram. I'm making a very generic diagram. Don't think that this is the accurate representation of what I'm trying to make you understand. Okay, so this is where the gusset plate is, the black thing which I have drawn, and behind that is going to be another member, which will also be a L section or a angle. I hope that this is clear to you, the plan which I just explained. And now let's come on to the detailed elevation which is there. So here you can see there are the same members. This is the in yellow. This is the concrete block in which there is a rag bolt which was colored. I did not color it back then, but now I will. So I will color it with red so you can see it clearly. This is the rag bolt which is being used to fix the base plate and the cleat to the concrete block. And then there is the cleat again. Here is the cleat, and under that is the base plate. I'm sorry, I flipped the colors. Sorry. So this is the cleat, and under that is the base plate. This is sort of just a revision. So I hope that it is not confusing because I expect better of you guys. Okay. Now the one in purple is the principal rafter, and the one in orange is the gusset plate, and the one in dark green is the main tie. So all these things are also mentioned here. You can easily guess what it means. Now this is the wind filling. Wind filling is given because wind at times is very strong, and because these members are individual and sometimes only being fixed using bolts and ties and purlins, which can be light as compared to the force with which the wind is blowing. So here a wind filling is provided so that it can hold the structures together. Okay, our last few things left. Now this is the covering, the roofing, which is asbestos corrugated sheets. Now what I want you to do is search for what corrugated sheets, asbestos corrugated sheets are, and what the different kinds of roofing materials are there available which are used with trusses. That is the assignment for you to do. And the last thing probably after this would be the advantages of using steel in trusses. Now, advantages of steel trusses are that trusses are usually built with mild steel. So as in the previous video we have discussed what the good thing about mild steel and why using mild steel is so convenient. So that is the thing. Then the working stress for a mild steel truss is 20 times that of an ordinary structural timber truss. So the material is stronger, it is more durable, it needs less maintenance, and the weight that it can carry is 20 times more. The working stress is 20 times more than that of timber. Now, for different spans, there are different kinds of trusses. Like we saw all the schematic and the generic drawings of them in the video before right now. And erection of steel trusses is rapid and economical, like any structure that is being built with mild steel. Steel trusses enable large columnless spans to be built without the restriction like in timber slabs. So in timber, there's that restriction that you can't join many large members together without having vertical support beneath them. So that is not a problem that you have in steel structures, as we understood in the previous slides how the structures are being built. There are nodes and there are smaller members and there are other members which are helping us join all the members together. Then trusses have a greater fire resistance. Like we discussed in the previous video, fire resistance is very important, and even though steel is not fireproof but fire resistant, it takes time to reach the critical temperature for mild steel or steel to be affected. Then the last point is steel sections are lightweight and are easy to fabricate in shapes and sizes to suit the requirements. So unlike timber, you can fabricate the structures as per your need, as you want, in whatever shape, size or properties you want. So customizable materials are the one in demand, and thus that is one of the biggest advantages of steel trusses. Now what I want you to do is do the assignment which has been given to you. Search for the covering materials which are used with trusses except for asbestos sheets, corrugated asbestos sheets, and please write that down in your sketchbook as well. I will see you in the next video.